Diamond value is predicted by carat, depth, table, color, clarity. I'm not an expert on diamonds, so I don't know what these are. Maybe some of you are. But let's just say these are some numbers for diamonds, and according to these things, you can evaluate the value of a diamond. And there are several questions you can answer by this table. By the way, this is the output of an Excel spreadsheet if you run the multiple regression. And some of these values are purposely left blank so that you have to figure them out. Okay? All right, so looking at this, first question. How many lines of data are there? Okay, where do you see?
2.
No, you can't have multiple regression with just 2 variables. And
5.
5? No.
29.
6.
Okay. Anyone have a good idea of how to get it? Yes.
Is it 6?
No.
I thought it's all the things under in the set.
Okay. I think what you guys are confusing is the number of predictor variables with lines of data.
Oh.
You're confusing those two. Okay. The lines of data is the raw data. Okay. So what you're assuming is that you have a spreadsheet with information of the carat, depth, table, color, clarity, and the diamond value, how much it sells for. Okay. From that, if you generate this, you get this. Okay. But see, the raw scores are hidden from you, and you have to figure it out. Yes, you have a question?
You're solving for n.
You're solving for n, right? How?
24 equals n
Right.
minus.
So you're trying to say that 24 is equal to n minus.
3.
Okay, so this is the degrees of freedom, right? Degrees of freedom of the residual. Right? And you've learned it as n minus 2 because we are learning it in the context of simple regression. Okay? But here it's multiple regression, so it's not just n minus 2. It's really n minus 1 minus. What goes in there?
Number of predictor variables?
Yes, number of predictor variables. Okay. Now, how many predictor variables do we have?
5.
We have 5. We're using 5 variables to predict the price, right? 5 of them. So that's 5. So we really have n minus 6 equals to this degrees of freedom, so that n must be 30. So although the raw data is hidden from you, from this output, you can already see that that shape of the data must have been 1, 2, 3, 4, 5, 6 columns and 30 lines. Okay? 30 lines of data. Okay, so the answer to this one would be 30, just because of that. And we already answered how many predictor variables are there. There are 5. Okay, now the question is write the multiple regression equation. And before we actually write the multiple regression equation, you have to first figure out what the form of the equation looks like. So, see, the multiple regression equation is y hat equals to b0 plus b1 x1 plus b2 x2 plus b3 x3. And when do I stop?
6.
b4 x4 plus b5 x5. You stop at 5 because there are 5 predictor variables. You only have x1 through x5. Okay. Yeah. And some of you said 6 because there are 6 terms here. Okay, and then these values are these coefficients. So I'm afraid I don't have enough room to write it. But let me try to write it. We write it here. Y hat, all right, small, negative 16462.37 plus 12604.511 times x1 plus 280.780 x2 79.719 x3 plus I don't want to do this, but I'll have to go to here. Negative 2911.95 x4 plus negative 2434.868 x5. Okay. So this long thing is the answer. Okay, so that's the multiple regression. Okay, next. What percent of variation is explained by regression? Yes?
78.2.
Yeah. So it's the adjusted R squared, right? Yeah. Okay? It's the adjusted R squared. Do you know the name of R squared? What's the name of R squared?
Row.
No, it's not. The name is, yes?
Coefficient of determination.
Very good. Splendid. Yeah. It's called coefficient of determination, okay? And adjusted R squared just penalizes for having too many predictor variables, because the more predictor variables you have, it's easier to get better explanation power, but you need some trade-offs. So that's what this adjusted R squared is, but we'll use adjusted R squared for the multiple regression. So the answer to this is 78.2%. Okay. All right. Now predict the price of diamond of 1.85 carats at 60.35, table 58, color 4, and clarity 5. How do you do this?
Plug into the regression equation.
Yeah, this, okay, so what does y hat mean? Can you tell me what y hat mean?
It's just this.
When you see this y hat, what does it mean? This y hat is the prediction, okay? Y hat is your prediction. What if you just have y without any hat? What's that?
The confirmed number.
Those are the actual values, okay? What do you call the difference between y and y hat? If you do y minus y hat, what's that called?
What's your butt? The residual.
Residual, yes, very good. So that the difference between the y and y hat is called residual. And in a broader context, it's just simply error. If you have a prediction and the actual value, the difference is what we call the error. Okay? In the context of simple regression or multiple regression, that's called residual. Okay? So hopefully you know these concepts before you actually do it. So because this one says predict, what are you looking for? You're looking for y hat. And because of that, you must be using this equation. So you actually have to punch this into your calculator, and it's just too time consuming, so I asked a few people to actually do it for me. Did you get an answer? What did you get?
$14,602.61.
Can I get a confirmation? Did you get that as well?
Yeah, that's right. Yes.
That's right. Okay, great. Okay, so that's what you get if you put 1.85 here, 60.235 here, 58 in here, 4 in here, and clarity 5 in here. Is that good? All right. Now let me move over to the next question, F. And here's where it gets a bit serious. Okay, so F is the hardest one in all the questions here. So probably F is the hardest, G is the next hardest, and the remainder ones are like pretty straightforward. You don't have to think too much. Okay, so let's see how to do F. Here, it's asking to determine the overall significance of this multiple regression. And as I said, this is missing some values. In order to get the overall significance, what you need to do is you have to use something called the F statistic. Okay? An F statistic is like if you have like samples of data drawn from normal distribution, two kinds of normal distribution, and you take the sum of squares and you take the average of the sum of squares of the two and you take the ratio of it, it tries to see where that value would be at. Okay? And the F-test statistic, if you draw the graph, it looks something like this. Okay? Can't be negative because you're taking the ratio of sum of squares, and sum of squares are always positive. Right? And whatever value you get for the F-test statistic, let's say this is your F value you got, then because we're always using the right tail for this multiple regression significance, you're really looking at this area. That's going to be your p-value, and p-value gives you the significance of your multiple regression. Okay? So, therefore, the way you do it is you have to follow these steps. So first, you have to figure out what the mean squares are, and then take the ratio of the two. That's your F-test statistic. And then from that, you use your calculator, FCDF, to figure out this area, and then that's the answer. Okay? So that's the overall idea. Okay. Should I repeat that or?
Yeah, one more time.
Okay, one more time. Okay. We find the mean squared. How do you get the mean squares?
Sum of squares divided by degrees.
Sum of squares divided by degrees of freedom. You do that, and you get these two values, right? And then you have to calculate the F-test statistic. How do you do it? You divide these two. You get your F value, okay? And then after you get the F value, you punch it into your calculator, FCDF, and that gives you your PDF, your P value, okay? That part I'll explain a little bit more in detail, okay? But first of all, what we need to do is to calculate the mean squares. Let's fill this in here. So that's a huge number, 501735799.927. Now, it's very possible that I'm making an error when I punch these numbers, so I really want everyone to try this before me to get a confirmation. So I get 100,347,1599. Is that what you get to?
Yeah. Okay,
thank you. And then you have to do 1105,3428. 62.539 divided by 24. And this one I get 46055,952.61. And then right. And then now you have to now divide these two numbers. So let's figure out the F value. So I divide 100,347,1599 divided by the previous answer. And I get 21.78. 788. Okay. Is anyone following this with their own calculator? You got the same answer? Okay, great. So I got some confirmation that this is indeed the value. Now let's try to use this to get the value of the P. So what's happening is here I have 21.788, and I want to get the area from 21.788 until infinity. So what you want to do is you want to go to second vars. So you do second plus bars, and that gives you the bunch of distributions. And in the menu, if you scroll down, you'll see the number 10 or something like that at F, C, D, F. Okay. So you're going to press enter, and depending on your calculator, some of you just will have to punch in these numbers manually, or some of you get the menu where it has the lower, upper degrees of freedom numerator, and you have to put these numbers in. Okay. Okay, but so first what you have to do is you have to punch in 21.788 here. So let's put that in, 21.788. Okay, and then for the upper you have to plug in infinity, but calculators don't have infinity, so what should you plug in? 1 million, just some really high numbers. So I'm going to put 1,000,000, 1 million. And so I'm going to put 1 million. Okay, and then you need the degrees of freedom of the numerator. So for this number, what's the degrees of freedom of this number here?
5.
It's 5, right? And the degrees of freedom of the denominator is 24. So those are the numbers that you have to plug in, 5 and 24. So let me put those in, 5, 24. And if you paste it, you get something like 3.307 e negative 8, which means 3.307 times 10 to the negative 8th power. Okay. So if you actually write this out as decimals, what does that mean? It's 0.00000003307. Okay, it's at the 8th place. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay. That's what this value is. So, is that very significant or not significant?
Not significant.
No, it's very significant. Okay. The closer the p-value is to the 0, it's more significant. Because just getting these numbers by chance is very small. That's what it means. Okay? Significance means just getting those numbers by chance is very small. There must be some linear relationship between the diamond value and at least some of these predictors. Okay, so that's what it means. Okay, now the questions are a bit out of order. If I were to rewrite this, I kind of, as I'm doing this, I'm kind of regretting the order. I should have put this as number 1. And then ask this. Now, why? Well, the reason is the following. If this value doesn't come out as very significant, then it means that, can we trust this regression equation?
No.
No. So when you're being asked to predict, can you use the regression equation? The answer is no, you can't. Okay? Then if you can't use it, what should you use instead? Now, if you can't use the regression, just use the average value of the diamonds in the table, and that's your answer. Okay? Of course, that's not given to us, so we can't answer in that case. So we really had no choice when we were solving E. We were using it thinking that since we're not given the average value of the diamond values, we don't have any other choice than to use the regression equation. But if you had access to both, then you have to make a choice depending on your significance. Okay? So if your significance level is like 1%, then this is under, so it's very good. That allows you to use this. Okay? All right. Any questions so far? This is the most complicated one with the most steps, so I really want you to review the steps that we took. Okay? You first find the mean squares, then take the ratio, calculate the F-test statistic, and then using that value, you have to get this area by using the FCDF. Okay, that's how you get the p-value of the significance. All right, so if you understood that, then that's very good, because that's probably the hardest one for the next exam. Okay, but here goes the next part. This is the second hardest. Construct 99% confidence interval for the coefficient of clarity. So clarity is this one right here. And the current value is negative 2,434.868. But if you had more data, then this value will change. Right? And if you had all the diamonds in the world, if you took the census of all the diamonds in the world, then again you'll get some value that will be different from this. Right? So you have to question whether this coefficient that we got from the sample is believable or not. Okay? And because of that, when Excel spreadsheet outputs these values, it also has, after the p-value, gives you the lower 95 percentile and the upper 95 percentile, which means it's the confidence interval of where this could be. Okay? If you actually had a census, where could the actual value be lying between? Okay? So the question right now is to construct a 99% confidence interval. All right, so the basic idea is to use the following, that the margin of error, or just simply MOE, margin of error, MOE, margin of error, is the critical T value, T critical value, times the standard error. And the standard error is like the standard deviation. And that means you first have to figure out what the T critical is. Okay? How do you get T critical? You use inverse T, right? So you use inverse T of, okay, what's the value of alpha?
1 minus 0.01 divided by 2.
Right. So you have to do 1 minus 0.01, because alpha is 1 minus 0.99, so that's alpha value, right? So you do 1 minus 0.01 divided by 2. And then you have to provide the degrees of freedom. What do you use for the degrees of freedom? You use the residual degrees of freedom. Okay, so you use 24. So here, this is the degrees of freedom that you should be using. Okay, so let's actually put this into a calculator and see what it tells us. Okay, I'm going to do second distribution inverse T. Area is 1 minus 0.01 divided by 2. Degrees of freedom is 24. I enter, and I get 2.797. Okay. And therefore, the margin of error would now be 2.9797 times what?
1301.773.
This one, yes. It's that one. Yeah. I was looking at the wrong one for a minute. So it's 1301.773. Did anyone do it for me? Are you doing it? No? Times 1301.773. It's going to be 3640.98. Okay. And therefore, the confidence interval would be, this is the center, but it could be 3,600 more than this value, or it could be 3,600 less than this value. Okay? Because this is a 99% confidence interval, the confidence interval is rather very big. Okay, so the answer would be negative 2434.868 plus or minus 3640.98. 240.98. And here's another thing I want you to do. Since it's a bit hard to see what this is referring to, I really want you to write it as an inequality. So let's try to write this as an inequality. So let's do negative 2434.868 minus 3640.98. And the result is that it can go as low as 6075.84. And it can go high as, if you add these two, so plus you get 1206.11. It can go as high as this value. So if you add these two, you get this. If you subtract the two, you get this. Okay. And now it's really, I'm really trying to see what you know to put here. What should I write here? No, it's the coefficient of what? It's the coefficient of the clarity, right? What's the symbol for that?
It's an x5.
No, it's the coefficient of x5. What? B5, right? So that's the thing, okay? So you want to say that B5 is between these two, right? Okay. So last question here. What variables are most influential predictors of diamond cost at 0.05 level? Now, I was doing a similar question the other day, and I misread the question, and I'm afraid I gave you a wrong answer. But it's not wrong. What I said was correct, except that it's wrong because of the misunderstanding of the question. So, if you read closely, it's not asking for the most influential predictor, it's asking for most influential predictors. So because it's a plural, you have to find all of them which are influential. Okay? So look at the p-value. If you're at 0.05 significance level, which one of these are significant?
Caret and color.
Caret and color, those are below 0.05, right? These are not so significant. They're actually not so trustworthy. So if I were to run this multiple regression and looked at this output, I'm going to run this multiple regression again because I realize that the depth and table are not good predictors. I'm going to get rid of that, okay? And for clarity, it's like still something, right? So I'll have to think a little bit. But if I make up my mind that I want 0.05 significance level, I'm going to get rid of that as well. But you know, sometimes if you just go with the 3, the significance could change as well. So I would just try to run it with the caret and the color and clarity, just these 3, and run it. And if it still comes out as above 0.05, I'm going to get rid of it. Okay. So right now, the answer is caret and color. So in other words, when you're given these questions, and what threw me off is this word most. Usually if you say most, then it's singular, right? You look for just one thing that's the greatest, right? So if you look at the practice exam, you'll see that I don't have this. I'll just say, what variables are influential predictors of diamond cost at 0.05? That's the wording I use. I don't like that word most there. Okay, but anyways, anything that's under this, anything whose p-value is under the given significance level, you write them all. That's how you do it. Okay. Okay. Do you have any questions regarding this?